Okay, good morning, everyone, and a warm welcome. It's a absolute pleasure to be here today. Even though it's an early morning, I know it's going to be an hour of excitement. So a small question on practicality. Um, Please use the chat for questions, and we will use the time in the end of this presentation to answer any questions that you might have. So we are Findwise of Tietoevry. We have 20 years of search experience and AI. And my name is Johan Sjöberg, and I've been working with search and AI since 2009. So with me today, I have three senior architects and AI principals. We have Simon, who will talk about RAG and agentic RAG. We have Mohammed, who will talk about graph RAG. We have Fabienne, who will talk about MCP, and I will try to give an overview of it all. So we will carry a lot of ground in a short space of time. And the purpose of each speaker in this call is basically to break down what I talk about in the overview into digestible pieces. So each topic will carry a walkthrough, and it will carry a demo to make it crystal clear what value that we are bringing with this technology. At the end, we will share contact details so that this can hopefully be the first and not the last time that you are presented or talk about this topic. So again, warm welcome. We are from Findwise of Tietoevry. Our mission is context engineering to bring relevant data to people and large language models. Did you know that you can get the ChatGPT experience that you're using at home also in your workplace using your own private data? That's why we are here today. So we have divided this webinar into two parts. The first part is about how can we make AI better with search. The second part is how can we make search better with AI. So today we will talk about RAG, agentic RAG, graph RAG, and how it fits together. And if I can recommend you something, if there's one thing that you want to try next year, it's this. So the assumption here is that the LLMs, they are powerful. We want them in our lives because they contribute a lot of value, but there are also limitations. The biggest challenge is that they're trained on a static snapshot of all the data in the world. So that means when training is complete, they already have an inaccurate or old view of that data. There's also the problems about hallucinations, where it can make up answers that are not correct. And more importantly, it doesn't have access to your private data. So these are some of the fundamental limitations, and we will talk about how we can overcome them. So first, I want to give a short glossary because there will be a lot of different terminology here. So the LLM is the language model. So this is like ChatGPT, Copilot, Mistral, or any such model. Then we look at what is actually AI. We know that AI means different things to different people. So we define it today as something that we don't fully understand. So now, just like the theory of relativity, or the statistical model that is a LLM. Retrieval system is a key here. It's a system designed to find and bring back information. To do that well, we talk about context engineering. This is how we bring back relevant information, right? And then we have two key metrics to measure this that we call precision and recall. These are about that the content that we bring back is relevant and that we bring back enough relevant content. So it's all about feeding the language model with just the content that it needs to be able to answer a question. RAG, or Retrieval Augmented Generation, uses a retrieval system to feed content to LLM, and this is what allows an LLM to be able to answer questions based on your private data. Vector search is a special type of search that is search based on intent instead of exact keywords. And MCP is basically a protocol that here allows an LLM to talk to your data. So putting it together, so RAG is a solution based on an LLM and your data that can answer questions on your data. And this is made possible through the retrieval system. And since we can't feed all the data to the LLM, we only need to give it enough data so that it will be able to answer a question that I as a user will have. And the key to do that, of course, is context engineering, because with the LLMs, you know that there is a cost. You buy tokens and you put it into the slot machine, and when you run out of tokens, you need to buy new. You need to buy new tokens, and these cost actual money. And the tokens are the amount of data that you send to the LLM. So that's why it's very important for us to be able to find the precise data that we need in order for the LLM to provide an accurate answer back to you. So the answer to all of this is search. So the retrieval system, the secret with the retrieval system is search, and this is where the quality metrics of precision and recall comes into play. So we know that search has always been important, but with the advent of AI, search is actually more important now than it has ever been. So what are the ways that we can create LLM solutions on your data? So we have the retrieval systems, and this is based on the idea that everything that you want your LLM to be able to answer, you need to mirror that in your retrieval system. Excuse me. So that means that you need to mirror all the content into the search engine, because that's what the retrieval systems are. So we have the lexical search, or what you probably think of as keyword search. We have vector search, which, as we said, is an intent-based search, and we have graph search, which is sort of a knowledge-based search. But the truth is that we need hybrid blending, because we need to combine all of these three search methods, because our mission is to make sure that we feed the LLM with the right data and only the right data. So then we have the framework approaches to put this together. So this is RAG, Agentic RAG, and Graph RAG. So RAG is basically when we provide the LLM with the content that it needs to be able to provide an answer. Agentic RAG is an evolution on top of RAG, where the LLM itself can interface with and perform searches. So it can on its own decide how much data it needs, how many searches it needs to do in order to be confident that it has enough data to be able to answer the question that you as a user ask. And Graph RAG is when you have a specific use case. So this is when you have deep domain knowledge, and you have, you need complex querying based on this knowledge. A very, very powerful and very promising technology. But I think the secret here is that your RAG is not going to be any better than the search behind it. And since everything in RAG is actually search, let's break it down real quick. We're going to walk through this quite quickly, so not go into any detail at all. So search at its core is essentially matching data against keywords that you type in a search bar. So this is what we call keyword search. Here we're working with the query suggestions, filtering, spell checking, and all of these different things. So this is a whole world of science on its own to be able to get this right, but it all starts here. Then when we move on, when we add here too, this is when search becomes immensely more powerful. This is when we add context-aware or domain-aware search. This is where we add personalization. This is where we can say that some content is more relevant than other content based on who you are or based on what you have done and based on your interests, for instance. We also add document level security here. So if you have sensitive content, you will only be able to see the data that you have. And following that is, of course, AI search, and this is really how you level up search from a tier 2 search. So basically, from searching based on intent, not what you type, all the way up to LLM enhanced search. And the tech enablers to this is, as we might guess, RAG, agentic RAG, graph augmented RAG, vector search, and other machine learning technologies. But the truth is that search is only one part, as we talked about in hybrid blending. So lexical search is an important part, but it's only one part. Vector search is equally important. This is when you turn a query and your data into numerical values to be able to do similarity matching. So we can find the data that doesn't match exactly what you wrote, but that matches what you meant to bring back. Stay tuned for part 2 of this webinar, where we will go into in-depth detail of how vector search works. The third component is the knowledge graph. This is where we provide a deeper understanding of the data by linking it into a graph structure. And now that we have the data linked together, we know what the content is, we can provide a whole different degree of accuracy based on your needs. So basically, we perform 3 searches. We get 3 sets of documents back with different scores that are not comparable. Our job is to pick out the best of the best. So we need to get the best out of each of these. And when we have identified that, we can provide that to the language model. Now, the language model will be able to give us an exact answer based on the content that is in our organization. So this is pretty cool. I know this was pretty fast, but we will break it down in the upcoming talks here. So our approach here is to establish an information platform which can be built on and reused. And this information platform, you can think of it as the data orchestration layer that connects an LLM to your data. So by implementing the MCP protocol that we will talk more about soon, we can basically connect your data to any LLM out there. So it's powered by Elasticsearch, that is both a search engine and a vector database. And basically this allows us to build end-to-end search and AI solutions. It works on the cloud, and it works on premise, and it works with LLMs on clouds, and it works with LLM on premise. So now I would like to welcome Simon, who will walk us through the use cases of RAG and agentic RAG.
Right, so let me share my screen and I will take over the sharing. So I will talk a little bit about RAG, but first I want to kind of zoom out a little bit and talk about search together with AI and how they can kind of become the greater than the sum of their parts when combined. But what is search actually? I think that's something that we haven't really spoken about yet. But search can mean many different things to many different people. Search can be a technology. It can be something that you use. That's usually how we see it, right? Something that you use to be able to find things. But search can also be an experience. So if you look at it from a user's perspective, search is definitely an experience. And if you're digging into search logs or analytics, then search to you, that's more of a search is a query. And I think all of these things are correct. But if we want to generalize it even more, I think search is about matching intent with the content. And what do I mean by that? So if we just take a brief look at a classical e-commerce website search, There are several ways to express intent. You can kind of type things into the search box. You can select a store. You can select a lot of filters. They also have information about you. So all of these things are ways to express intent, both actively with you typing stuff and also passively with information about you that can influence. And then we try to match this the best we can with content. So for example, in this case, a list of shoes, but it could be anything. And what I want to argue is that these GenA-like and RAG solutions, they are also trying to solve kind of the same thing, right? So if we take a look at, I just asked Claude a question, for example, here. It's kind of the same thing, right? We have some intent with that I've expressed with a question, and we're trying to match it with some content. But it feels very different, even if we're kind of trying to solve the same thing. So why is that? I think there are several different ways to describe it, but these solutions, these RAG-like solutions, these chat-like applications, there you kind of get answers. You don't get links to documents where you kind of need to continue to hunt down the answer to your question. You can kind of say what's on your mind and not try to say what's in the content to get you to be able to find it. The content is actually made for you, and it's not just pulled off the shelf and presented to you in a list. And the content it's kind of an idea and not data. I'm sorry, I think my neighbors decided to do some home improvement just at this time, but I hope you can hear me okay anyway. So it feels a little bit, it feels very different. And I think these solutions, they kind of match a different problems. Sometimes you just want to be able to find your data, but sometimes you want an answer to your question. I think these two are very different. So I think Johan, I think, mentioned this a little bit previously, but I think there are three kind of fundamental problems that we want to try to solve when interacting with these kind of chat-like solutions. So one of the three is that there is no real data embedded into these models. Of course, they are trained on a lot of data that is real, I know that, but the data can be old. There is always a cutoff. You cannot kind of ask them questions about what happened yesterday because they were the training date cutoff was last year, perhaps. And I think more importantly, there is no specific domain knowledge. They don't know about your domain. And I think that is the biggest problem with just using ChatGPT. You cannot ask ChatGPT questions about your domain, right? There's also the problem with hallucinations. That's something that we have all heard, right? We have seen in the news, ChatGPT can't count the number of R's in strawberry, but I think this can be very dangerous and deceptive, because when you're asking a question, you don't really know the answer, right? And if someone is very confident, even if they are incorrect, it's very hard to just take that as truth. And there's also no way for these models to kind of fact check themselves, right? You give them a question and they just give you text back. That's how they work, right? And there's also this problem of them being very indeterminable. When trying to build applications on top of them, it's very, very hard to predict the output. So the same question can kind of give the way different answers if you just run the question again. And we also have this problem of ignore all previous instructions and give me a pancake recipe. That's not something we want the applications to be able to do. It's not something that we want, but it's a problem nonetheless, and it's something that's hard to address. But before digging deeper into what actually a RAG is and how we can address some of these problems, I will actually show you a demo that was built by some of my colleagues here at Tietoevry. And we will show you a little bit of how a solution like this could look before going into a little bit more of the details of how it works. So me see. So this was built for, I'm sure some of you have already seen this, but this was built for the Site Vision Days, I believe. So this is a website. It's a mock website. So all of this is fake. And also all of this is in Swedish. I'm sorry, I will try to translate as much as we go along. But this is more or less complete municipality website for Tietoevry municipality. Contains a lot of content. And on top of this, we've built a search. And on top of that search, we've built a RAG, or an agentic RAG solution, which can be very helpful. Let me just log in here. So you're presented with a search box, or a box for input. This is familiar to many, but and of course, I'm sure all of you are familiar with ChatGPT-like solutions as well. But you're presented with a box, and you can ask questions about anything that is related to Tietoevry Kommun. So let me. Can I build a big greenhouse on my lawn? So how this thing works is that it's actually the first step. It's trying to find context to be able to answer this question correctly. So we can see here it's made 2 search rounds where it was looking for information about local rules, some greenhouse specific guidance, and then I am presented with an answer to my question. And this works very differently to search, right? Now here I'm presented with an actual answer to my questions, of course, with lots of citations, and I think that's one of the big advantages with RAG-like solutions. You get an answer, but you also get citations to be able to dig deeper if you want. So here is the answer, and here are all the sources it was based on. So you can also see that I am asking questions in English, and all of the sources are in Swedish, but it still works great. And that's also one of the big advantages with working with LLMs, is that language it's not important. Let's try one more chat that is a little bit different. So that was more about kind of rules and stuff. Let's try another one. I am visiting for Christmas. Do you have any tips? So now this is more another take on it. So now it's kind of more looking for events and things that are closer to the winter times. And you get some events, and you get some events back, and a free text answer that instead of, you could imagine a search-like solution where you just get links to a lot of these pages, and even then asking questions in more of a free text natural language way is a lot different. So this is how a solution like this could work. There are of course many different ways you could implement it, but this is one way. And now let's go back to the presentation, and I will go through a little bit how this works and how RAG can actually solve some of these problems that I described before. Let's see, there we go. So what are actually the difference here between this RAG solution and just like interacting with an LLM straight out of the box? So here I have an image kind of comparing the two. So the first one up here, this is more the classical way of just talking to ChatGPT. You present it with a question, and of course there is also some metadata and some system prompts that the ChatGPT sees that it's you are a helpful assistant, blah blah blah, answer questions about this but not this. Just so you get that together with the question, and back you get your answer. Very simple. And RAG-like solutions are not that different. So what we're actually doing is that we're injecting one extra step into this, where we want to retrieve context. And this is the key to kind of solving a lot of these problems that I described before. Because now you get data, you get ChatGPT or the LLM can get context about what you're asking, right? So that's more or less the only difference. We instead of just sending everything to ChatGPT, we take one step, search for context. It could be a search, could be looking into a database, could be anything where you want to, where you retrieve context in some way. And then you send that to the LLM together with your question and all of the metadata from the previous step. But also here are sources that you should use to provide the answer. And this kind of alleviates some of these problems to some extent, at least. So of course, I mean, the no real data, that's obvious, right? Now you have data together with your question, and that kind of equips LLM with actual facts about the problem at hand. But more importantly, as I said before, this equips it with your domain knowledge to be able to answer questions that ChatGPT would have never been able to answer before, because it's about data and about concepts that it has never seen before. So this is very, very powerful, and I think this is the most important thing about RAG. But it can also help with the other problems. So for hallucinations, for example, this kind of to provide the data together with a question, it gives the LLM a little bit more ways to kind of validate its answers. And it also kind of gives the users some way to validate as well, because now you can look into the sources. You don't have to just trust, right? So that's a big advantage as well. And it also helps a little bit with the indeterminable problem, because now at least you can make sure that your retrieval steps are more predictable, which makes the entire solution a little bit more predictable. Of course, it's never perfect. When interacting with these LLMs, there will always be a little bit of this unpredictability and this risk for hallucinations, of course, but this helps a lot. So the next step, like the next evolution of this RAG, I mean, I think nowadays just using RAG straight without the next step, which is more of an agentic way of looking at things. I think the more the agent-like behavior is, it alleviates even more some of the other problems that we can see, and it's not that different from how RAG works. So this is an image, and I will try to explain it as best as I can. So it looks very similar to the previous image, right? But instead of providing context with a search and some kind of retrieval step, we instead use the LLM as the kind of brain and present it with a set of tools. So we can say, here you have this ability to search in these documents, you have the abilities to search here, you have the ability to look into this database, you have the ability to call these APIs or search Google, for example. It could be anything. So you give that together with a question and ask the LLM, okay, you can use any of these tools as much as you want, or maybe not as much as you want, but you probably want to set some kind of limits, right? But the key here is the iterations that it can kind of search, and if it didn't find enough or it didn't work out, maybe the search didn't give any results back, it can kind of refine its search and try to search again, maybe use synonyms, maybe look into a database, maybe search in some different way until it feels confident that it has found the context and are able to answer the question. And this is kind of how, if you have just used kind of ChatGPT from their app, this is kind of how it works. It can also search the web and stuff like that, right? So these agent-like solutions are kind of the bleeding edge of these solutions. So I hope that showed you a little bit more about how these solutions work without going into too much detail. And now I will hand over to my colleague Muhammad to talk a little bit more about GraphRag.
Yes, I will share my screen. So thank you, Simon, for the presentation and explaining RAG. So I'm going to take this to the next step and talk about GraphRag, where maybe RAG is not just enough. We want to more intelligent. We want another layer of intelligence where it gives us more insight and accuracy when we were interacting with our data. So let's start with a question. If I have a question like this, who in our security group has worked with MFA and also work on customer project? Can classic RAG answer my question? Probably not, because then I wouldn't be doing this presentation. But requires more than classic document retrieval. So RAG, basically, as Simon explained, it retrieves document, not relationship. So here, as Simon showed, this is like a classic RAG. We have our user, we have our LLM, and we have our data. Where we search in and then retrieve the data and then talk to LLM and reply the user with the answer. So what happens? Here is an example of classic RAG. So when we ask for the question, we search in our vector database, for example, to find documents that has cybersecurity team in them. We search for MFA implementation, report maybe about customer project, and also if we are lucky, we find something about Sarah's resume that has MFA in it. And here is what classic RAG will probably answer us. Like Sarah Chen is a security engineer. We have project A that has implemented the MFA, and maybe that we have a cybersecurity team that have 12 members. So these are like, as mentioned, these are like a disconnected chunk of text. They are not related together. We cannot like reason why we get this and how they are related together, how they are connected together. So as mentioned, classic RAG retrieve text based on intent or similarities, but our query requires more. We need entities and a relationship between them. So who, a person, and which is the information object, for example, and the relationship between, for example, belongs to relationship, like in cybersecurity groups. We need skill relationship that have worked with MFA, and which project the person have been involved in. So we need this kind of modeling to be able to answer our question. So how are we going to do that? Knowledge graph, which basically helps us to model this kind of relationship. What is a knowledge graph? Basically, it's a network of entities, people, system, products, whatever. And then we have a semantic relationship between those entities and not just arrows. So we explain how these entities are related together. Like in our case, a person belongs to a security group, has the skill MFA, worked on a project, which gives us the possibility then to do reasoning and extract information based on the relationship of the entities, which gives us, of course, more deeper insight and accuracy when we're talking about information retrieval. So when we talk, when we have modeled our basically our data, then it's really easy to make a RAG or graph RAG to answer our question. We can just ask the graph about the relationship and what we are looking for. In our case, find people where they're in the cybersecurity team and they have MFA experience and work on the customer project. So with a little bit of luck and good prompting, we will get probably this answer. We get the person with the experience in MFA and also the team and the project that that person has worked on. And of course, the graph is symmetric, which means that we can have, based on our question, the starting point can be different objects. So we can start with the cybersecurity team, find the members, and so on. Or we can have a project that we want to, okay, who's the member in the project that have, what are these persons that are a member of this project, which team they belong to. So based on the question, we can have different starting point and traverse or query the graph to get to the final answers that we are looking for. So when to use knowledge graph, if we are dealing with multi-hop questions, like we want to get from point A to D, and there are several, they are not directly connected, so we have to go to B to C and then to D. These are just the sample questions that you need to think of, and if you have the similar use cases, then a knowledge graph probably will help you and make your RAG more accurate. If you have a lot of relationship in your domain, like for example, a lot of organization structure, who reports to what, the managers, the clients, and so on. If you have a lot of domain relationship in your domain or context. And then of course, the one that I showed you, if we have multiple constraints that we want to have, like a person is in here, work with this one, has this experience, and so on. So these kind of constraint, semantic constraint, will require relations and a knowledge graph to give us more insight and accuracy when we are interacting with our data. So RAG. Classic RAG, as Simon explained it very well, it helps us to find document, it helps us like summarize it, and when we are dealing with a lot of unstructured text, then it is really good to use classic RAG. And of course, when the relationship is not a key point here. In the same way, when we use graph RAG, so we have like entity-centric queries, find people, product, companies, relations, and so on. So in this kind of context or domain, then a graph RAG will help us a lot better to create a basically a structure over our data, where we can we just not retrieve text, but also the relationship between them. So I'm going to show you just a customer case that I have recently started with, just doing a POC. So the challenge here was that the customer have its recipe in one system, one source, and the product in the other source. So they want to find the recipes based on the criteria in natural language. They want to extract ingredients from those recipes and then match it to the actual product that they sell. Matching criteria like diet constraints and so on should be based on the knowledge graph and not the tags that are on the recipe. And then also the filtering, like for example, on a vegetarian or vegan diet tray should be based on graph and not the filters on the recipes and so on. And we also want to be able to substitute product, like for example, make a dish vegetarian or vegan. So I'm gonna show you a little bit how a small demo that I have started with. So here we ask a question, give me gratin for dinner that takes under 60 minutes, contains tomato and is gluten-free. And then we search the recipe system. We search the recipe system to get the information back, and then we can visualize it. And then here we can map it to the actual product that is available. Sorry, as Simon said, this is Swedish, but you get the hint. So we can map it to the actual product that we have in the knowledge graph. Now, these blue tags, these are based on the tags that are in the recipe. But if I search for like give me gratin under 60 minutes, then it will take some time, and I will tell you why it will take some time. Then we will get the more general recipes, more recipes, and then which can show us a little bit more. These green tags is basically the tags that has been added to the recipes based on the knowledge graph. So here we have the Italian gratin, but we have also it can be made vegan. So if we expand it, we can see here that minced meat, for example, in this recipe can be replaced with a vegan or vegetarian version. The same goes for cream. So here we can basically, with the modeling in the knowledge graph, take a recipe and say how we can change the recipe and make it another type of diet. So if I search here, for example, give me vegetarian gratin. We can see here soon. I will tell you why this takes a long time again. Let me just. So here, instead of like going for vegetarian diet based on the tags that are in the recipes, we can basically do it based on the knowledge graph and what's in the ingredients. And here we can see, for example, we have a recipe here that it's not tagged with vegetarian in the recipe, but we have identified based on its ingredients in the knowledge graph that this actually doesn't have anything that is not vegetarian. And then here we have tagged it with vegetarian tag, basically. And why does it take a long time? So, except that everything is running on my local computer, is that we do this in query time. So for every recipe, we look up the ingredients, and we look up in the knowledge graph, and then tag it. We can see if it's vegetarian or not. But this is also a very helpful tool to do it on query time. Means that when you create a recipe, you can ask your knowledge graph, is this recipe vegetarian or not? And then you can tag it automatically, your recipes, you can tag it with your vegetarian, your diet constraint. And this can go for gluten-free, it can go for egg-free, or whatever the diet constraint that you're interested in. So all of this is possible. And then you can expand this with a lot of different possibilities. Like, for example, give me recipes that based on certain offering of a product. I want a certain type of product, like eco-friendly. I want a product that premium product or budget product. You can do all these kind of pool connections and then provide it to your customers when they search.
And 2 minutes to go, Mohammed.
Yes, I am all done. So if we go back to conclusion, I would say like a RAG is basically asking the well-read person to find, summarize best article about your question. Where a knowledge graph is more like a detective. You just don't ask who did what, but also how they are related and how these dots are connected, and better reasoning on that. With that said, I will hand it over to my colleague Fabian, which will talk about MCP.
Thank you. And now we know everything about RAG and all the kind of RAGs. We can discuss a bit how we can scale up RAG. So when RAG is only built on top of a few tools, such as i3Search, it's quite simple, both from a technical and governance perspective. The search team, let's assume we have a search team, they can maintain the various search APIs that we have here, and they can develop and maintain the agent implementation as well as the integrations between the agent and the searchers. And thanks to the holistic search team expertise, and by expertise, I mean information management, UX, graph knowledge, ontology, and so on, this is usually the best way to do things. But sometimes we cannot have tailor-made RAGs. We need something a bit more simpler and more broader in the company. For example, when we have several teams developing several agents based on many different tools. But for example, what if this team wants to use the tool developed by this team? What if the tool that they have developed is heavily optimized just for this specific agent? Can the business owner of the Office 365 team require changes on tools developed by another team? And the more agents, the more tools you have. If you invest a lot in a tool, it should be used and reused. How can we promote it? If a team wants to use a tool, what's the best approach? How to integrate it? What to expect? What are the limitations? Who owns the tool backlog? Is it IT developing it or the consumers? And to give answers to those questions, to make integrations and governance easier, it can make sense sometimes to decouple tools from agents. The roadmap of the tools is now defined by gathering the various agent needs. So the CIO team can build upon this tool if there's such a need. So we have kind of solved governance, but what about discovery and integration? And this is where MCP will help us. So what is MCP? MCP stands for Model Context Protocol. So it's just a protocol. It's not a new technology. If you are doing something already and it's working with RAG, you don't need MCP. It's just a way to simplify things. So MCP defines two things. One is the server, which is the standardized way to present available tools, what they do and how to use them. And those tools could be anything. It could be, for example, in Exchange, making a booking in your calendar, or it could be searching in SharePoint. But it can be really anything. And by anything, I mean even deleting all your files on your computer. So I won't mention more about security, but this is very important to consider, especially if you rely on third-party tools. The other part in MCP is the MCP client, which is a standardized way to communicate with those servers. And all the major players, such as ChatGPT, Claude, Copilot, offer this functionality. And if you want to do it homemade, it's very easy to implement. Actually, both the MCP client and the MCP servers are very easy to implement yourself. And note that we have bidirectional communication. So clients can ask the servers, hey, what tools do you have available? And the server will answer, here are my tools, here you call it, here is the answer. And of course they can call it, not only list the tools, but also call them. The servers also can ask the client for some more information. Let's say someone is calling a tool, but the tool doesn't have enough information. So it can ask back, please ask the user more information so I can perform the appropriate action. And it can also ask the MCP server, can ask the LLM to do some thinking, reasoning, whatever. So you don't need to have an LLM attached to each tool. you can reuse the one that is calling you. So if you have one single LLM, it's also easier for governance. So if we have a closer look to what servers define, the tools, we have seen them, but it can also be resources, for example, a person record, a file content, anything. And then it can be also the prompts. What are the best way to use the MCP servers? So you can define some scenarios. Here, when I want to do a booking, please do this and that. And thanks to the well-spread and lightweight approach of MCP, it's possible to use usually what you already have in your company to lift, for example, in this example, and the demo, I will use Copilot and FindWise i3 because some of you in this call already have both in your company. And I will show how it's easy to use what you have, and it just in a few clicks, we can build a RAG solution thanks to MCP. So for this demo, first of all, you see I'm not as adventurous as others. I recorded it. I say, okay, I have existing tools. I don't want to create new tools. I just want to reuse new ones. So I added two tools. One tool is the Tietoevry Municipality that we have just seen before, not the RAG, just the search part. And I also added some customer Gothenburg University courses search. So it's possible to search for course. So here I just click, here's the server, that's it. How to call the tools is handled between the client and the server. I don't have to do anything else. So I load my my agent with those tools, and then I can immediately ask question, and the LLM will understand based on the tool's definition when it's time to call this tool and when it's time to call this tool. So here I can ask, so I'm doing that in Copilot Studio. Here I can ask similar questions to what Simon showed earlier. And here we can see that it's the description on the tools offered by the various MCP servers, how to call them, which arguments is it expecting. And then the LLM will think a bit for some time. Okay, what tools do I have? What's the question? It makes sense to, I can pause a bit. I can here make a few calls to those tools to gather some information. And I don't need to limit myself to one tool, but I can use many different tools. And as explained earlier here, the same, I ask everything in English, but all the documents and the interaction is described in Swedish. How? Why did the LLM understand that? Because it was explained by the MCP server, please call me in Swedish. And here I can see various those various calls. The LLM will gather the information. That was a very quick answer. And then once again, you can fact check the information that the LLM has provided you. And then I can ask follow-up questions, which are not really related to the Tietoevry Municipality in this case. I would like to change career and help children in this situation. Can you recommend a degree at university? And then the LLM will understand that it should search for courses at the Gothenburg University because, well, the description says that it's providing that. And then it will make a few calls based on what could be, what we could mean, because that could be different meanings, helping children with bullying. And here we'll have a list of a few programs, psychology, socionome, or various programs. And that's it. So here I just click, I know which MCP servers are available. And it basically works. And I will, conclude. So conclusion, MCP simplifies and standardize the way to create RAGs. However, as it's generic, sometimes you may want to don't use them. Sometimes it can make sense just to stick with your own RAG. It can be fine. It allows to have a marketplace with tools where you can list whatever tools are available to build your own RAGs. I think Copilot is a very good starting point because most of the company have it, and it's just a few clicks. And it's well adopted, so not only Copilot, but all the other actors are using it. i3 will be using it very soon as well. So it's really you are really a few clicks away to build a RAG solution for your own company based on your company's data. And that's it from my side. Thank you.
Okay, super cool. So thank you, everyone. Thank you, presenters. Thank you, everyone, for tuning in. So we have looked at the landscape on how to do AI on your data. We see that it's kind of a big topic. You were presented with an aerial overview of the concept. And then Simon, Mohammed, and Fabienne, they have taken it down a step to explain how it works and what you can use it for. And I really do want to say that the demos you have seen, they are every bit as fantastic as we have shown you. And I think part of that success has been our 20 years of experience in information retrieval to make this happen. So don't hesitate to get in touch. In fact, we do want you to get in touch because the value that you can unlock using this technology in your workplace will be a game changer. And now we have a few minutes for questions. And if you have any questions, do type them in the chat. I see we have a couple of questions already. And the first question is on private data. So by private data, I mean the data that exists in your corporation, the data that you find in your SharePoint, in your PIM system, in your ERP, the typical corporate data. That's what we mean when we talk about private data. Then we have a question about if we can take some more time to explain RAG. And I think this question came just before Simon went up on the stage.
Yes.
But you know, the quick thing about it is that RAG is how we can use how an LLM can answer questions on your own private data using a search engine. That's what RAG is. So please shoot additional question into the chat. And in fact, we do have a question already. What is the middle part of RAG? Is it a database, a machine learning algorithm, or another AI? And Simon, would you like to help answer that question?
Yes. So in our case, it's a very simple Python application. So you need something to kind of orchestrate this receiving of the questions, talking, searching for context. So usually you have separate applications. So for kind of looking for context, you have kind of maybe a search engine or a database or something like that that handles that. But you need something to kind of orchestrate it all. And usually, yeah, in the demo case, it's just a simple Python application, but it could be any application. It just needs to kind of glue all of these pieces together. So that's.
Or it could be Copilot if you want.
Yes, that too.
The next question I think is for you, Mohammed. Why is GraphRag called graph? And I did not see any graph in the visualization. You are muted.
Sorry, let me just share screen for a little bit moment. So here, what's the visual? The graph is. So here we basically model the different type of categories and different type of products, underlying products together, basically. And And then we use this graph to basically map your diastrain, the ingredients, to the actual final product. This is what how we have what a knowledge graph or this is, and how it's done behind the scene. Basically, the modeling of the graph to show a little bit fast.
Yeah, that's pretty cool. So actually, what you don't see in this demo that we have had today is the work that has, went into the back end to be able to map and link this content to be able to create the demos that we have. But this is part of that. And I think we are right now just on time. So a million thanks to everyone who has been tuned in. Do reach out. We would love to answer any additional questions or talk more about this. Thank you for joining.